Hi, welcome to the Ashok channel Physics. This is another video on electric current, which is a cell constructions. In the previous videos, we cleared the concepts about electric field, potential difference, and the drift velocity, and what you mean by the resistance, and the factors affecting the resistance, and the equivalent resistance when they are connected in series, and equivalent resistance when they are connected in parallel. All these concepts we have explained in the previous videos. If you have doubt, you can check the previous videos, and please subscribe the channel so that support my journey. Then I will put more number of videos to clear the concepts. Please subscribe the channel. Thank you. Okay, so now I am entering into the new concept, which is a cell construction. And we said about, if there is a circuit which is having a resistance, and if it is connected to a battery, it is said to be the higher potential and it is said to be the lower potential, and when it is connected to a circuit, then current moves the direction of current. I said the direction of current is nothing but the direction of the positive charges. Then current always moves from higher potential to lower potential. So this is the direction of the current, and in the metallic conductors, the current is caused by the electrons, which is moving opposite to the direction of flow of current. Then electrons moves from lower potential to higher potential. Here the electrons will get repelled by, electron is said to be having a negative charge. Then negative, this is said to be the negative terminal, and a negative charge will get repelled by this negative charge, and as there is a repulsion of the electron, then electron moves in this direction and enter into the positive terminal. This is the direction of the electrons, which is opposite to the direction of the current. If current is moving in the clockwise direction, then electrons moves in the anti-clockwise direction outside the cell. And inside the cell, electrons moves from higher potential to lower potential inside the cell. Electrons moves from positive to negative, and again they will come out of the cell from negative to positive. This is the direction of the electrons. Here there are two questions you are going to get in the exams. What is the direction of electrons outside the cell? Outside the cell, the electrons are moving from negative to positive, and inside the cell, don't get confused here, inside the cell the electrons are moving from positive to negative. Again they will come out of the cell like this, and inside the cell they will move from positive to negative. So what is the direction of electrons inside the cell? Inside the cell, they are always moves from higher potential to lower potential. This is said to be higher potential, and this is said to be lower potential. Inside the cell, electrons moves from higher potential to lower potential. Outside the cell, electrons moves from lower potential to higher potential. This is also for current. So outside the cell, current moves from higher potential to lower potential, and inside the cell, current moves from lower potential to higher potential. So these are the directions. Don't get confused on them. So these are very important questions also. Okay, so now we are discussing how a battery develops a potential. Here a positive potential is developed on the battery at one terminal, how a negative potential is developed on a battery at another terminal. So this is what we are going to discuss here. Okay, then here I am considering a battery. Battery is supplying the energy to the electrons. So here the electrons are moving, that means that there is a force is applied on the electrons. In order to apply a force, an energy is needed. That energy applied on the electrons is said to be the electrical energy. By taking the electrical energy, electrons are moving in the circuits. From where that electrical energy is supplied? From where electrical energy you are getting? So that electrical energy on the electrons you will get from the battery. Battery itself, it is having an energy which is in the form of chemical energy. So the battery is said to be inside a battery. You are having a chemical. That chemical is having some chemical energy. That chemical energy is supplied to the electrons. By taking that energy, electrons will move inside a circuit. As the energy is supplied, there is a force applied on the electrons. That force will drive the electrons in this direction, as there is a resistance which can restrict the flow of electrons. By restricting the flow of electrons, the energy of the electrons is converted to another energy which is converted to heat or light, or it can convert into the mechanical energies. So this is what happens. So then how there is a chemical energy is developed inside the cell, that we have to discuss here. So the construction of the cell. So a cell is having a chemical inside that. So now we are discussing about a electrolytic cell which is converting a chemical energy to the electrical energy. So inside a cell we are taking some H2SO4 here. A H2SO4 solution is taken, which is a dilute H2SO4. So if it is diluted, then you are having the free ions, which is H plus and SO4 minus. So in the H2SO4, when it is diluted, so for a H2SO4, when it is diluted, that means when it is going to dilute, when you are adding a water to the concentrated H2SO4, so when it is dilute, then you will get 2 H plus ions and SO4 2 minus ions. Now these are said to be the ions, a positive ion and a negative ion. So now as they become ions, they can get attracted. A positive can get attracted towards a negative, and a negative can get attracted towards a positive. So that means if you put a negative here, then these H plus are going to attract towards negative. If you put a positive there, then SO4 2 minus is going to attract towards the positive. Okay. So now you are having H plus ions and SO4 2 minus ions, 2 H plus ions and SO4 2 minus ions are there in the dilute H2SO4. Okay. When you are inserting a zinc here, a zinc rod is inserted here. When you are inserting a zinc rod, what happens? Now this SO4 is trying to mix with zinc, so then it becomes ZnSO4. So this SO4 2 minus, so generally SO4 2 minus ion cannot mix with zinc atom, so it is going to mix with zinc ion, not with zinc atom. So what do you mean by the zinc atom and zinc ion? So Zn is zinc atom. Now this SO4 is not going to mix with the zinc atom. It is trying to mix with the zinc ion. Yeah, this is said to be a ion. A ion always mix with another ion. So then this zinc will become a positive ion. Like it becomes Zn2 plus. As it is become Zn2 plus, it is trying to lose 2 electrons. This Zn becomes Zn2 plus. Why it is become Zn2 plus? So as it is becoming Zn2 plus, then this Zn2 plus will mix with SO4 2 minus. Then it becomes ZnSO4 2 2 plus is mixing with 2 minus, then it becomes a compound ZnSO4. So which is at a lower energy state, ZnSO4. Compare with H2SO4, ZnSO4 is at a lower energy state. Always atoms are trying to be at their lower energy state. Okay. So now this Zn2 plus will mix. This Zn2 plus will mix with SO4 2 minus. Then you will get ZnSO4. This SO4 2 minus is trying to become as ZnSO4, which is at lower energy state. So always atoms are trying to be at their lower energy states. Okay. So when this SO4 2 minus will mix with this one, this Zn becomes Zn plus. Zn becomes Zn2 plus. And when it becomes Zn2 plus, 2 electrons are released from Zn. 2 electrons are going to release from Zn. If another SO4 2 minus is trying to mix, then another Zn is trying to become Zn2 plus. As it is becoming Zn2 plus, 2 electrons are again removed from the Zn. So in such a way that you are always, as one SO4 2 minus is mixed with the Zn, then you will get 2 electrons. If another SO4 2 minus is going to mix with the Zn, then you will get 4 electrons. If 3 SO4 2 minus are mixed with the Zn, then you will get 6 electrons from Zn. Likewise, you are getting so many number of electrons on Zn plus. So many number of electrons are there. So many number of electrons are released from Zn. And this Zn, by releasing these electrons, Zn becomes Zn plus. Okay. So up to what level this is going to happen? Always SO4 2 minus is attached to Zn? No. See, as there is a negative charge is developed, after some time there is a repulsion caused by this negative charge on SO4 minus 2. This is a minus charge and there is a negative charge is developed. And this negative charge can repel this negative charge so that another SO4 2 minus cannot come towards Zn. Then there is a equilibrium state is attained. So this negative repulsion does not allow one more SO4 2 minus to come towards Zn. So then Zn becomes a positive rod here. Okay. So now you are having the electrons. There are so many number of electrons are accumulated on Zn rod. Now if you supply, these electrons are trying to attach with positive electrons have a tendency always move towards positive. Suppose if there is a positive charges available here. So as Zn becomes Zn plus, in order to mix with SO4 2 minus, this positive rod Zn plus is trying to repel this H plus in the backward direction. This Zn plus, so Zn becomes Zn2 plus in order to mix with SO4 2 minus, then Zn2 plus is trying to repel this H plus ion in the backward direction. So if it is a copper rod, then this copper rod is accumulated with the positive charges until an equilibrium state is attained. As copper becomes positive, then as copper on the copper rod charges, positive charges are accumulated, then copper becomes a negative. So this becomes a negative, and copper becomes a negative and zinc becomes positive. So that's why we are saying zinc acts as positive rod, copper acts as a negative rod. As it is acting a negative rod, positives are attracted towards copper. As zinc is acting as a positive rod, negatives are attracting towards zinc. This is what they said. Then what is the process behind this one is this one. Okay. So when this copper rod is attached to zinc rod, then these negatives are trying to move towards the positives. And positives are trying to move towards the negative. Then there is a flow of charges. Always these negative charges are trying to move towards the copper and mix with a positive. When a negative is mixed with a positive, which is positive here H plus. So then an electron is mixed with a H plus, two electrons. Here the two electrons are moved from this one. Those two electrons are mixed with two H plus ions. Then you will get H2, which is atom. Now this is ion H plus ion, then this one becomes an atom H2 gas. Now you will get the bubbles, H2 gas bubbles inside the liquid. Why do we get the bubbles means these negative atoms, those two electrons are repelled or released as Zn becomes Zn2 plus in order to mix with SO4 2 minus. Those two electrons are trying to mix with positives, which are positives here H plus ions. Why do these positives came here? Because they are get repelled by this zinc rod. So then they are going to mix with two positives, two electrons mix with two positives, then you will get H2 gas, which is you will get in the form of bubbles. Then you can see the bubbles which are rising in this solution, H2 bubbles. Okay. So now as one negative comes here, then there is equilibrium state is disturbed. So that means if two electrons comes here, then another SO4 2 minus can move towards the zinc rod. Okay, so that means another SO4 2 minus you will get by splitting from H to SO4. So you will get another SO4 2 minus will move towards in this direction. As two electrons comes here and mixed with the H plus, then you will get H2. That means there is a deficiency of two electrons. Those two electrons will be made again by splitting SO4 2 minus ion from H to SO4. Again this process is happening from first again. Again from H to SO4, one SO4 2 minus will break out and it is going to mix with Zn2 plus, and in order to become Zn2 plus, again two electrons are released from Zn, and when there is a Zn2 plus and this SO4 2 minus is moving in this direction and mixed with Zn2 plus and becomes ZnSO4. So this is the process, and here these electrons are moving. Here the electrons, now this is said to be the negative potential. As the negative charges are developed, this is said to be negative potential. This which is positively lower potential. This is said to be lower potential. And positives are accumulated here, and this is said to be at higher potential. So here copper is at higher potential and zinc is at lower potential. This is the zinc rod and this one is the copper rod. Why it is said to be the higher potential? Because positives are accumulated, which is said to be the positively higher potential, and here negatives are accumulated, which is said to be the positively lower potential. So always here the negative charges are moving from lower potential to higher potential. outside the cell. This is the chemical. Chemical is the cell which is outside. It is moving from lower to higher. And inside SO4 2 minus, that means negative, is moving from higher potential to lower potential. Inside the cell, SO4 2 minus is moving towards the zinc. Outside the cell, negative is moving from lower to higher potential. This is also, you can compare with this one. Outside, negatives are moving from lower to higher. Outside, negative is moving from lower to higher. And inside battery, SO4 2 minus is moving from higher to lower. So this is the direction of the charges. This is how the charges are flowing in a battery. Okay. So this is the simple construction of the cell, and this is said to be the cell, and this is outside the cell. Higher potential and there is a lower potential, and positives are moving from higher potential to lower potential, negatives are moving from lower to higher potential outside the cell, and inside the cell SO4 2 minus is moving in this direction, that is from higher to lower. Negative is moving from higher to lower, and H plus is moving in this direction, that is from lower to higher inside the cell. Okay, so this is the construction of the cell, and you can explain this one with so if you understand this one, now I will explain this for a metallic conductor. If you are having a metallic conductor which is connected to a cell, this is a cell, and this is said to be the positively higher potential, and this is said to be positively lower potential. That means that is said to be the lower potential, and this is said to be the higher potential. And current moves. Current is nothing but flow of positive charges. Here positive charges are moving in this direction. That means from higher potential to lower potential. This is a higher potential, so current moves from higher potential to lower potential. This is the direction of current. And negative charges are moving. Negative charges are moving in this direction, that is from lower potential to higher potential outside the cell. So here negatives are nothing but here which are the charge carriers in the metallic conductors, which are electrons. So that means here the electrons are moving, electrons get repelled by the negative terminal. So that means they are moving from lower potential to higher potential. So this is the direction of the electrons. So here you are having the positive charges are accumulated. Here the negative charges are accumulated. So a negative charge, a electron which is here will get repelled by this negative charge and moves in this direction, and here you will get a negative charge, that is electron. Electron moves in this direction from lower potential to higher potential, and inside the battery it enters and it is at positive. Now this electron has to move towards the negative. Is it? So now this electron has to move towards the negative. That means there should be a work done. Why? Because this negative charge is not wanting to move towards the negative charge. Generally, a positive charge is trying to move towards the negative charge. So, in the cell, there is a repulsion force by these electrons in this direction. Electron, electron. That means this negative charge and this negative charge will get repelled. This is the force of electric force, which is the force obtained by the negative charges, that is electrical force. And here also there is a repulsion force between these positive and positive. This repulsion force is in this direction. So force of repulsion is in this direction. Here also force of repulsion is in this direction, which is the electrical force. Between the charges, between the electrical charges, there is a repulsion force. That's why it is said to be the electrical force. Okay. So now there is a chemical force is also there. That chemical force is trying to push negative from positive to negative. Here SO4 2 minus is moving towards the negative terminal, that is lower potential. Here SO4 2 minus is trying to move towards the lower potential. That means a negative here, if an electron is moving from here to here, you will get a negative. Now this negative is moving, then negative moves towards the negative potential. That means that is not electrostatic force. So you will get a force which is non-electrostatic, that is a chemical force. So then a chemical force acts on this electron. That chemical force will push the electron. So it pushes the electron against the electrical force. There is a electrical force is acting in this direction, and that chemical force is trying to push the electron in this direction. That means chemical force is doing a work in order to move the electron against this force, electrical force. There is an electrical force in this direction. Now that chemical force is trying to push that electron against this electrical force, which is doing the work here. Which force is trying to move this electron? A chemical force is trying to move the electron. That means here there is a work done. There is a work done inside the cell. That work is in order to move this electron. So electron is moving from here to here and comes here. And this electron never wants to move towards the negative charge. A negative charge never wants to move towards the negative charge. It always moves away from the negative charge. But it moves away from the negative charge, then our circuit is not completed. Our circuit is completed when electron is moving from here to here and it moves inside the cell in this direction. That means this electron is moving inside the cell in this direction. But in order to move, it does not move on its own. Negative never wants to move towards a negative. Then there must be a work done. Someone has to do work in order to move this electron towards the negative charges. So which is doing that work? So here a chemical force is doing that work. So then there is a work done by the chemical force in order to move this electron from this point to this point. Work done in moving a charge. There is a work done in moving a single electron. So then work done in order to move this electron from here to here, that is said to be the potential difference inside the cell, which is said to be the EMF. Potential difference between the cell, inside a cell. See, here, this electron, again I am saying simply, this electron is repelled by these negative charges, is moving in this direction and enter into the battery. When it enters into the battery, electron is a negative charge. It never wants to move towards a negative charge. Then someone has to do the work in order to move that negative charge. Someone has to do the work. So then which will do the work? So this electrical force does not do a work. Other than electrical force, so there must be a work done. So then a chemical will do that work. A chemical force is trying to push this electron in this direction. Then that is the chemical force which is trying to push that electron in that direction. As there is a work done on the electron, then electron will gain energy. So because in order to move the electron, so chemical has to apply its energy on the electron. So when it comes here, that energy is stored in the electron. Then electron is having the energy when it comes here. Now the electron is having the energy. So with that energy, electron again comes out of the battery. Now the electron which is coming out of the battery is having some energy. Why? Because this chemical is applying a work, this chemical is doing the work in order to move that electron from here to here. Then energy is stored in the electron, that when an electron is coming out of this battery, then that electron is having a maximum energy. With that energy, as it is having the energy, again electron moves That energy is carried towards a bulb or the fan, and energy is spent here. Whatever the energy is gained by the electron here inside the battery, that energy is spent here, which will drive the bulb or which will drive the fan. And as the energy spent here, electron comes with no energy here, and again when it comes here, then the chemical force will give the energy to the electron, and again electron coming out of this battery is having the energy, and again it spends energy here, and energy becomes zero, it comes to the positive, and again there is a energy stored in the electron inside the battery. So here inside the battery, who is doing the work to move the electron? Inside the battery, in order to move the electron from here to here, who is doing the work? A chemical is doing the work. So then, that work done in moving a electron, EMF. This is said to be the EMF, which is called electromotive force. So electron motive force, electron is motive. So electromotive force is nothing but work done in moving a charge, either a positive charge or a negative charge, but in the metallic conductors it is a positive charge. Work done in moving a charge, there must be a work done. If work is not done, then electron stay here, it does not move to the negative terminal. So on its own, it never wants to move towards a negative terminal. In order to move that electron towards a negative terminal, someone has to do the work. Then only energy is stored in the electron. So who is doing that work? Chemical. Work done in moving a work done by the chemical force. Work done by a chemical. Who is doing the work here in order to push the charge? A chemical is doing that work. Work done by a chemical in order to move a charge where? Not outside the battery, inside the battery. Work done by a chemical force in order to move a charge inside the battery. In a battery means inside the battery. Work done by a chemical force in order to move a charge in a battery from one terminal to another terminal. From one terminal to another terminal. That is said to be the EMF. Work done in moving a charge, generally it is called potential difference. Already I said what is the potential difference definition. Work done in moving a charge, that is said to be the potential difference from one point to another point. So EMF is also a potential difference, but this potential difference is inside a battery, in a battery. EMF, so the name itself indicates it is a force, electromotive force, but this is not a force, this is a work done in moving a charge. So this EMF is nothing but a potential difference inside a battery. That potential difference is maintained throughout the circuit. So this is how the electron completes its full path. Okay. So while an electron is moving inside a battery, it may offer some resistance, which is said to be the internal resistance. So when this electron is moving inside a chemical, this is filled with some chemical. When this electron is moving inside a chemical, there are some dust particles or something is there which can oppose the flow of electrons. So the opposition in the flow of electrons is nothing but resistance. Then inside the cell is also having a resistance is there. So a resistance is offered to the flow of electrons by the chemical force. That is said to be that resistance is offered inside the cell. That resistance is called internal resistance of the cell. Because of the internal resistance of the cell, it does not gain the full energy. Electron does not gain the full energy which is given by the chemical force. There is a decrease in the energy. Because of the why there is a decrease in the energy which is given to the electron? Because of the resistance provided by the battery. The energy is nothing but a potential difference. Then whatever the electron which is coming out here then it is having a less energy than we expected. That is said to be the terminal voltage. When it is coming from this terminal to this terminal, there is a collision between there is a internal resistance offered by the cell. Because of the internal resistance, the electron which is coming out of the cell is not having the entire energy which is a battery having. So that remaining energy is said to be the terminal voltage. Now you understood what is the EMF and what is the terminal voltage, how the electrons are moving inside a conductor. Okay, so this is a construction of the cell, which is very simple if you understand the concept. So you need to understand that. So it is a very simple language. Where is the repulsion and where is the attraction? Here is the repulsion to the negative charges. Here is the attraction. When the electron comes here, it does not move on its own. Someone has to do work in order to move that one. Who is doing that work? A chemical force is trying to do that work. Okay, that work done by the chemical force in order to move a charge inside a battery from one terminal to another terminal, that is said to be the EMF. And the terminal voltage is nothing but when there is an internal resistance inside the cell, the electron which is coming out of the battery does not have full energy. There is a decrease in the energy. That means there is a decrease in the potential difference. It has a potential difference. Then outside the cell, electron is not having that 100% potential difference. Then there is a decrease in the potential difference. After a decrease in the potential difference, what is the potential difference applied on the electron? That is said to be the terminal voltage. So now you understand what is the terminal voltage and what is the EMF. Okay, so please subscribe the channel so that you will get the updates. You will get the notifications on the electric current, and in the next classes I will say about the electromagnetism. So here we are concentrating on clearing the concepts. Okay, in the next class I am going to say the Kirchhoff's laws, which are very simple. A junction law which is said to be the current law, and a voltage law is there which is said to be the loop law. So in the next class we will discuss them so that we can end this electric current with 2 classes. Okay, thank you.